The chain rule. The chain rule is one of our big objectives here in the first semester on how to find derivatives. What this is going to do is it's going to allow you to find the derivative of the composition of a function. This is why I had you decompose functions earlier on in this semester. And I'll do all the theory for you first, and then I'm going to teach how to do it in common sense, and eventually you'll get to the common sense, hopefully sooner than later. But what happens here is that if you have a function h of x, and that equals f of g of x, then you can find the derivative h prime of x by doing f prime of g of x times g prime of x. So what it is the derivative of the outside part at the inside part times the derivative of the inside part. Or back in the beforehand when we did our decomposition, if we let u be g of x, this is kind of the way I'll do my examples today. If u equals g of x, then h prime of x is going to be f prime of u times du dx. That's a u on top there, not an o. And so that's how you're going to see me do my composition here quite a bit. So let's just take a look at a lot of examples. We can combine our rules. We can combine our product rule with our chain rule. We can do trig functions with chain rule, all kinds of stuff. So let's start out easy. Let's say we have y equals the square root of x squared plus 3. First thing you want to do is you want to rewrite that as x squared plus 3 to the 1/2 power. Now remember from our decomposition of a function, what I'm going to do is I'm going to write it as u equals x squared plus 3. Find the derivative of that because you need du dx. So du over dx is going to be 2x. Rewrite y in terms of u. So y equals u to the 1/2 power. Take the derivative of this. So y prime is 1/2 u to the negative 1/2 times du dx. And then put your all your u's and du dx and all that stuff back in. So y prime is going to be it's going to be 1/2 times x squared plus 3 to the negative 1/2, which I'll put in the denominator in just a moment, times 2x. Simplifying it, this 1/2 will cancel with that 2, and ultimately your derivative should look like this. It should be x over the square root of x squared plus 3. Like I said, chain rule is going to seem a little bit overwhelming at first. It'll be something you catch on to very quickly because we just use it so often. A second example for you. Let's try to do like a little power thing here. I can generalize the power rule for you. If you have y equals 3x minus 2 to the 100. Now let's look at this one as derivative outside, derivative inside. I'm not going to write down my u's and stuff. My outside function is the 3x minus 2 raised to the 100. So the 100 power, that's my outside function. The 3x minus 2 is my inside function. So the derivative would be the derivative of the outside function. Bring the 100 down. So y prime is 100 times 3x minus 2 to the 99th. And then I have to multiply that by the derivative of the inside function, which is 3x minus 2, which is this part right here. So if I multiply by the derivative of that, it's multiplied by 3. So 100 times 3 is 300 times 3x minus 2 to the 99th. One thing that causes people a little bit of difficulty is when we have trig powers raised to a higher, trig functions raised to a higher power. And the reason why is because of how we write it. So y equals, let's just take an easy one, say the sine squared of x. Okay, really what that means is it's the sine of x squared. And you want to think of it that way because you want to think about outside function, inside function. So now that when I go to take the derivative of the sine squared of x, the squared part of it is the outside function. So y prime is going to be 2 times the inside function, the sine of x, to the first power, times the derivative of the sine of x, which is cosine of x. Most of the time, you won't see that first power written. And then the other thing that they'll trick you on a little bit is they'll write it as y prime equals, and 2 sine of x cosine of x is really just the sine of 2x. And so they'll condense that formula back down. And then the real pain comes in when we start applying like quotient rule, or let's do product rule. Let's say we do product rule and we have chain rule within product rule, and then a lot of algebra simplifying, and I'll go through the simplifying on this one. Let's say we have y equals 5x minus 2 to the 4th times 3x plus 5 to the 6th, and they're multiplied together, so we got to use product rule. And then to take the derivative of each function, part of the function individually, we have to use chain rule, because to take the derivative of 5x minus 2 raised to the 4th power requires chain rule. Same thing with 3x plus 5 requires chain rule, and then we have power rule within that. So we have all these rules going together. So here we go. Start plugging away. The derivative of the first part is going to be 4 times 5x minus 2 cubed times 5, because that's the derivative of the inside part, times the second function, which is 3x plus 5 to the 6th. We have to multiply it by that because of product rule. Do the same thing for the second part. So that's going to be plus 6 times 3x plus 5 to the 5th times 3. And then times, we got to multiply. Let me sneak that in here. We'll draw a little arrow. It's supposed to be 5x minus 2 to the 4th. That should be to the 4th. And that goes right there next to the 6x, or 6 times 3x plus 5 to the 5th. Then what I'm going to do is I'm going to take, this is a binomial, 2 big binomials. The first one is here, and then the second one is, this whole thing together, that whole thing together right there. And what I'm going to do is I'm going to factor out what they have in common, and I factor out what they have in common so that I can simplify it. And by simplifying it, I want to write it as the product of factors. So the first thing, go to constants. 4 times 5 is 20, and 6 times 3 is 18. They have a 2 in common, so take that 2 out. We'll be able to throw that away later on. And then after the 2, we want to find out how many 5x minus 2's do they have in common. This one has 3. That one has 4. So we have 5x minus 2 cubed in common. And then how many 3x plus 5's they have in common, and they have 5 of those. So 3x plus 5, and like I said, they have 5 of those in common. And then we've got to write a statement for what they have left over. This first binomial, like I said, if you multiply it out, that's 20, so it has a 10. And then it has 1 3x plus 5. And then the second one, 6 times 3 is 18. And then, so that I have 2 out front, so I have 9 of them left over. And then I have 1 more 3x plus 5. From there, we want to distribute the 10, distribute the 9, simplify what I have in brackets. And ultimately, when I write it as the product of factors, it's going to be 2 times 5x minus 2 cubed 3x plus 5 to the 5th times 75x plus 32. And the reason why we simplify it that far, the reason why we want to write it as a product of factors like this, is because then down the road when I start asking you to simplify or start solving your derivatives, set them equal to 0, get critical numbers and stuff like that, if I can just set each of these individually equal to 0, it's very, very easy. This algebra simplifying is going to be the hardest part of what you face. This is where you're going to need to get help if you need help along the way. Usually understanding derivatives, okay, but this simplifying part can be very tricky. So good luck, ask lots of questions. Check out some stuff on Khan Academy. He's got some more good examples. Ask me in class, whatever you need to do. Ask a classmate. But you got to get a real good handle on this chain rule stuff, and as we combine it with the other rules, this is a very, very important objective.